All right, hello, senior math. Today we're going to continue talking about z-score, just like what we talked about tomorrow or yesterday. We're going to do a quick review. I believe this first part you actually had as your warm up. So we're going to do a quick review of z-score, and then we're going to jump into talking about how we can do z-score backwards to find certain percentages. So let's say a theater notices that the number of people attending their performance have a normal distribution to them, with a mean of 166.3, sorry, and a standard deviation of 28.4. Let's find the probability of less than 15 attendees coming to their next performance. All right. So when we are doing z-score, we know the first thing we need to do is we need to change from our standard random variable. We need to change to a z-score. So in order to change from z-score, we're going to start by taking x, which is 115 for us, minus our mean, which we were told was 166.3, all divided by our standard deviation, which is 28.4. Plugging this into the calculator, we are told this equals 115 minus 166.3, then divide by 28.4, we get negative 1.806. So I'm going to round that up to negative 1.801. From there, we know we can change this into finding the probability that z. So we are looking for less than. So we know it's going to be z is less than negative 1.81. For less than, we know we just have to look up the number from the chart. So we just have to look up negative 1.801 from the chart, which if we pull that up, we can see negative 1.801 is going to be right here. So 0.03513. So 0.03513. And that would be your probability of less than 115 attendees coming to their next performance. Same idea with probability of at least 225 attendees. So once again, we want to change it. We want to start off by changing it to z-score first. So we're going to start off with the 225 minus the 166.3 divided by our 28.4. Plug that into the calculator. This is what we get. The 225 minus 166.3 gives us 58.7 divided by 28.4 gives us 2.07 if we round up. So we know we can change that into our z-score. So that'll give us the probability. Now we were told at least, so at least means the at minimum. So we know z is going to be greater than, because the minimum value we want is 2.07. So z is greater than 2.07. So we know this is going to be 1 minus the result of 2.07 from our z-score table. So going back to our table, we're going down to 2.07, 2.0, 0, 1, 2, 3, 4, 5, 6, 7. So 98,077. So 0.98077. If we plug that in the calculator, we can do 1 minus 0.98077. We get 0.01923. So almost about 2% is our number we're working with. And then lastly, the probability between 100 to 200 attendees. Now we know whenever we're looking between two numbers that we take our larger value and we subtract the smaller value, but first we need to turn both these results into z-score. So I'm going to start with my bigger number. I'm going to do 200 minus 166.3 divided by my 28, wrong button, divided by 28.4 And this z-score turned into 200 minus 166.3 divided by 28.4 gives us 1.19. That's our upper z-score, which we'll find in a moment. We'll look for our lower z-score as well, the 100 minus 166.3 divided by 28.4. Our upper z-score, 100 minus 166.3 divided by 28.4, turns out to be negative 2.33. What we are looking for, so we know this is turning into the probability that negative 2.33 is less than z, which is less than 1.19. We're looking that the z-score falls between these two values. So we know whenever we're looking for the z-score between two numbers, we have to find the upper result minus the lower result. So let's start with this upper result, 1.19. Let's find that first. 1.19, 1.1, and then 9 is going to be all the way at the end. So it's 0.88298. 0.88298. Then we're going to subtract our lower value, which is our negative 233. Negative 2.30123. So 0.00990. 0.00990. We can plug that into our calculator. And that is going to turn into 0.88298 minus 0.00990 gives us 0.87308. And that would be your result. So that's what we were doing yesterday. We found the z-score of less than, the z-score of at least, and the z-score of in between two values. And we were using that formula, that x minus mean divided by the standard deviation, to be able to change from our random standard variable, whatever numbers they were giving us, to that z-score so we could use the normal distribution chart. So we're going to continue using this stuff today, but we're going to look at using this stuff backwards. So given a percentage, can you tell me what number of result would be less than given so example, given 3%, can you tell me less than what number is going to result in 3% of attendees? And so we're looking for the 115. Or given 0.019, what number is going to be greater than that percentage of attendees at least attending? And we're looking for 225. So we're given the percentage to start with, and we need to work backwards in order to get the x that we're starting with. So if we kind of think about our probability with z-score steps, step number 1 is use that formula to get the z value. Then we have to look at the z-score number from the chart. And then the third step is we have to use one of those three situations, whether we were less than, whether we were greater than, or whether we were in between, to find the probability. And that just told us whether we needed to use a number from the chart, whether we had to do the 1 minus from the chart, or whether we had to do the two numbers from the chart subtraction, or the difference between the two. So we're kind of just doing those steps in reverse. So first step is to determine which of those three situations we have. So whether it's just a less than, a greater than, or an in between. Step number 2 is use the probability to find the z. So they're giving us a percentage. We have to look at that percentage on the z-score and work backwards. We were kind of doing this last Tuesday when we first started using normal distribution. I gave you a normal distribution result, and you had to look up the z that related to it. We're going to do that same idea. And then we're going to plug in z, the mean, and the standard deviation into our formula, and we're going to have to work backwards in that formula to solve for the x. So let's see some examples of this. So start off with number 1. So, what if the theater was wanting to figure out less than what number of attendees would show up to a performance 90% of the time? So, essentially, they're saying out of 90% of their performances, what is the biggest number that they should attend? What is the biggest number of attendees that they should always receive? So, I like to use a graph, like a little bell curve graph, to help me visualize this. So, I know that it's 90%. What number is wanting to figure out less than what number of attendees would show up to the performance 90% of the time. So I know that 90% of this graph is going to be shaded in. So 90% of this graph is going to be shaded in. So this represents 90%. Because this represents 90%, I know that z-score, our z-score table is always less than. It's the cumulative value below. So I need to look up where 90% is on my z-score table, because all of this range over here is the 90% below. So we're going to pull up our table, and we're going to see what is the closest number that shows up to 90%. So 0.90. So the closest thing that shows up to 0.90, if we look, we have 0.903, 0.901. So this number right here, in between these two values, is closest to 90%. Now they are very close to each other to be 90%. So this one is only about 16. Let's see, what is that? That's only about 27.0027 off of 90%. Well, this one's 0.00147 off. So we're going to use this number because this is just slightly closer to 90%. So 1.28, and I won't give you too many numbers that you'll have to actually look up. I will have you use the same ones multiple times. So 1.28 represents the z-score of 90%. So our 90% from our table, or 0.9000, is roughly pretty much equivalent to 1.28 as the z-score. We know now, essentially, because we are doing less than, because we were trying to find the probability that z was less than a certain number, we are essentially looking up, now that we have that 1.9 or 1.28, we can plug, we know it's going to be, 1.28 is going to be equal to, create my little bar, we know it's x, which is the number that we're looking for, minus the mean, which is 166.3, divided by the standard deviation, which is 28.4. So we just need to work backwards in this formula to solve for x. And luckily, there's always just a two-step process we're going to do. So in order to get x, the first thing we need to do is we need to multiply both sides by that standard deviation. I'm going to try to write this in the pen just to make it faster. So we're going to multiply by 28.4. And that's going to cancel out this 28.4 in the denominator because I divide by that. So the first step I should do in order to work backwards is to multiply it. So that means we need to multiply both sides by 28.4 because we're doing an inverse operation. So we're doing 28.4 times 1.28, which gives us a result of 36.352. And that's going to be equal to x minus the 166.3. So we're always going to multiply by the standard deviation first. And then the last step I need to do in order to get rid of my, is to get rid of my 166.3, I just add 166.3. We're just doing that opposite, or that inverse operation. So normally if I were to, if I'm subtracting, in order to get rid of it, I need to add it. So I'm going to add it to one side. And then I'm going to add to the other. So 166.3. So we just have to do our 36 36.352 plus 166.3, so 36.352 plus 166.3 gives us a result of 20. Oh, I didn't type it down. Gives us 202.652 equals x. And you could round that to 202.65, but this is your number. So given this x value, given 202.65, this would be the number of attendees that would show up at least 90% of the time. So 202 to 203 number, 102 to 103 attendees should show up 90% to every performance. We can do the same idea this way. So at least what number of attendees will show up 85% of the time. So 85% of the time, but it's at least what number? So at least we know is greater than. So that means the above value needs to be greater than. So when the above value is greater than, sorry, that means all of this space represents 85% of my data. So we're looking for 85% of our data being greater than the value. So this is 85%. Well, if that's 85%, that means that we know our cumulative z-chart is always going values, the cumulative probability less than. So if we have 85%, we need to do 1 minus 0.85, and that's going to give us our percentage that's below that value. Or if we think about 100 minus 85, that's going to leave us with 0.15 or 15%. So all the value below this is 15%. So that is the value that we're going to look up on our z-score, because we know our z-score table always does the stuff below the result, to the left of. So I want to find what is 15% from my z-score table. So we're going to look up 0.15000. We're going to try to find the closest thing to this on our z-score table. So 115. Now the closest thing to 1500 is going to be in between these two. This one right here is closer. So we're going to do negative 1.01234. So negative 1.04 is going to be our z-score. It represents 15% of the data to the left of it. So this is why I like to have the picture to help you with the situation, because otherwise you'd be looking up 85%, and that's not the number we're looking for. We want to look up the number that's below, always to the left of that value, which is going to be the 15%. All right, and now we just have to work backwards. So I know negative 1.01, or sorry, 1.04 should be my result, is going to be equal to my 1.663, my x minus 1.663, because once again, I'm solving for that x. And then divided by the 28.4. So we know we can inverse this. We can solve this by multiplying. We're always going to multiply first by the 28.4. The standard deviation, we're always going to get rid of that bottom part first. And those are going to cancel out. But that means I have to multiply this side by 28.4 as well. So if I figure out what negative 1.04 times 28.4, that gives us 29.536, which is going to be equal to x minus 166.3. So we always multiply by the standard deviation, and then we have to add the mean to each side, 166.3, because that's going to cancel out my mean. So this cancels out, and I am left with 29.536 plus 166.3 leaves me with a result of 195.836 equals x. So this is saying that the lowest number of attendees they're going to receive 85% of the time. So 85% of the time they are going to have more than 195.836 attendees. So essentially 196 attendees are going to show up at least 85% of the time. All right, last example, the in between. So between what number of attendees will show up 90% of the time? So this one's the hardest one because we're looking for in between. So that means the middle value, the in between result of our data is 90%. So all of this space in between these two numbers needs to be equal to 90. Well, that means I have two ends of my data that I kind of have to work with. So because all of this in between space is 90%, that means I need to split the rest of that 10%. That 10% I'm not using needs to be split between these two areas back here. So that means this spot back here is going to be 5%. And this spot up here is going to be 5%. But if I think about it, I'm always looking at the number to the left of my value. So if this is 5% to the left, and then to the left of this purple line over here is going to be 95, or is going to be 90 and 5%. That's going to be a total of 95%. So I essentially have to look up two different values on my z-score table. I have to look up 5% and 95%. So we have to find the x for both of those because we have to think between what two numbers. So once again, anytime we're doing between, we're going to get two results. So let's start off with the 5%. I'm going to start off with the lower one. So I need to think, what is 0.50000? What is that on my z-score table? So what is that z-score? So I'm going to look up closest thing to, sorry, that's the wrong number. It's 0.5 is 5%. Looking at my z-score table, we're going to look for 5%. So 0.05. 0.05 shows up. We're getting close. Right here. Okay, so that is negative 1.6. 1, 2, 0, 1, 2, 3, 4. So negative 1.64. This is one that you're going to use frequently. Negative 1.64 is a z-score we'll use frequently. So 1.64 is going to be equal to x minus 166.3, all divided by our standard deviation of 28.4. We know our steps that we need to take. First thing we have to do, we have to multiply by the 28.4 to cancel that out. So we'll do negative 1.64 times 28.4. Once again, this should be negative. So negative 1.64 times 28.4 gives us a result of negative 46.576, which equals x minus 166.3. We know we then have to add the 166.3. Both sides to cancel out my 166.3. This cancels out, and I am left with 119.724 is my low result. That's my 5% result. So I know less than 5% of the people, or 5% of the people are going to be below that value. And I just need to do this one last time before my other result. So that was my low result. Now here's the cool thing. If we look up 95% on our z-score table, because our z-squared table is symmetrical, 95% is also going to be between our 4 and our 5, but it's always going to be closest to that 4, so it's negative 1.64 again. But rather than being the negative, it's going to be the positive solution of it. So whenever you're looking up the two sides, that 5% and that 95% that both have 5% on the outsides of each of them, they're going to be the positive and negative versions of the same thing. So 95%, 0.95000, is going to turn into positive 1.64. So we're just going to use that same number, but we're going to use the positive in the negative instead of the negative version now. So positive 1.64 is going to be equal to x minus 166.3. We still have to do all the math though, because it's going to give us a different result when we add, divided by the 28.4. So the multiplication part's still going to be the same. So I'm going to multiply by 28.3, or 28.4, I'm sorry. And so this number gets multiplied by 28.4 times 28.4, which is going to leave me with the same result from before, except positive. So it's going to be positive 46.576. Going to give me the positive version, and that's going to equal to x minus 166.3. So the beginning part's still the same, but now when I add 166.3, I'm not just going to get the positive version of my other answer. I'm going to get something else because we're adding to a positive number rather than adding to a negative number now. So 46.576 plus 166.3 gives me a result of 212.876 is going to be equal to my x. That is my result I'm looking for. So in our final answer, we know between what two numbers will there be, will 90% of the people, or will 90% of the shows have their attendance of? Well, between 119.7, I'll round for these, which is less than x, which is less than 212.9 shows. So between 120 to 113 show, or between 213 people, should 90% of their shows have their attendance. So they can always assume they'll fill around these percent of the seats 90% of the time, which is very handy for businesses to know and be able to use these probabilities. All right, that's where we're going to end it for Z-Score Backwards. I will have GoGuardian open in case you need to ask any questions, but you have a little bit of practice that you can work with. Let me know if anything comes up, and I will try to answer as quickly as possible, but I might not get to you always right when you respond to me. But feel free to reach out to me. Have a great rest of your day.